remember correctly, on the border. Yeah, let's look. Let's look right here and see what we have. So even in that region that didn't look like we had a lot of data there, we actually have seven different scenes, so 7 different time periods where data has been collected. Let me see what we got here. Let's try this one, see what we have. So this is very, very close to the border. You can, again, see a lot of the infrastructure. This is an agricultural region. We're just putting this into the base map, different time of year on the base map. Yeah, so as we build up our capacity for collection, we can see a number of different things. I think it's here. I just wanted to highlight a bit of infrastructure. I think we're down here.
And again, this is just looking at our internal tool set. I'm not sure there are many other satellite companies that would just kind of lift up the hood and let you drive around in the internal tools. But
yeah, drive around North Korea. Yeah, the location, there was an airfield that I thought was quite interesting, but the location slips my memory right now. Might be over here.
So these internal tools are often where we test and prototype things that we then release to our partners like MapPoint Asia. But as always with live demos, sometimes they work, sometimes they don't. But we're absolutely willing to have a look at a few more areas, or if there are any other questions from the audience, I think we've...
Yes, please.
You already hinted at the timely discussion issue, the environmental issue there. But I must confess, as I follow, I only saw the haze.
Mm-hmm.
But perhaps the point of interest is that how much forest has been destroyed out of this bushfire since it started, let's say, from mid-February until today. And therefore, I mean, how do you present that? I mean, to the generalists, to the general public, in terms of the scale of devastation?
Yeah, no, that's a very good point. And that's one of the reasons why we're developing a network of partners like we have with MapPoint Asia, because just showing pictures here, I think some folks find this interesting, maybe some folks don't quite understand what they're seeing, because interpreting features and images takes some practice. I've looked at images for a while, perhaps you've looked at images for a while, you can see features on the ground, but if you wanted to communicate that in a general sense, that's when leveraging the temporal aspect of what we're doing, so being able to take an image once every few days of a fire that's been burning for several weeks, and then essentially measuring the extent of the smoke, measuring the extent of where the flames originate, and then presenting that either in the context of a report or in the context of, you know, a graphic on a map that's much more easily interpreted by someone who doesn't understand imagery. That's where our partners, were giving them access to all the data that we're collecting in the region so that they can begin to develop those services. Because I think, you know, as we collect more and more data, it's difficult for me to keep up with the amount of data we're collecting and just looking at it manually and doing interpretation. But having partners who understand GIS and remote sensing, and then they can provide services. So you may just subscribe to a service, maybe perhaps this time next year from MapPoint Asia, where they provide a daily map of smoke and fire conditions in northern Thailand between February and March, or typically when these fires burn. I think that would be a very valuable piece of information, and it saves you time in looking at imagery. So that's where I think a lot of this information is going. We're providing the content, if you will. Our partners are fine-tuning the tools because they understand how people want to consume this information locally. That's why I look at us less as a satellite image reselling company and more as an information company, that then our partners refine that information and present it in a useful manner.
มีคำถามเพิ่มเติมไหมคะ
There are question about the image accuracy in for the XYZ.
Yes, no, I appreciate you bringing that up. So I think Alex mentioned that our process is highly automated. For example, some of the images that just came through, let's take this image for instance. This was collected yesterday in Thailand, and you can see that it's a very smoky image, and yet we were able to orthorectify it in a matter of hours. Having a person do each image by hand is not scalable, and as we're adding up to 100 to 150 satellites to our constellation, we're going to get a lot of image everywhere, every day. So the process that we go through is highly automated. Once the data has been downlinked to a ground station, actually it doesn't matter where the ground station is. So this data of Thailand could have been downlinked to one of our ground stations in New Zealand, or it even could have been downlinked to one of our ground stations in the US or Canada, depending on the orbit of that particular satellite. But once that data is downlinked to the ground station, it immediately gets uploaded to our cloud infrastructure. So we have a cloud computing infrastructure that takes that data and automatically then does some of the image enhancement, image correction, and then does an orthorectification process that uses a series of seasonal Landsat data sets that we've created. So Landsat is a very reliable instrument that is operated by the US Geological Survey and NASA. It collects everywhere on the Earth once every 16 days. It's been going for about 35 years now, so we have a very rich archive of this data. So we use that data to basically tie our imagery to in a horizontal sense, in the X and Y sense, through a series of different types of feature recognition processes. And then we use a global digital elevation model for the Z correction. So in hilly areas, of course, you get some displacement by the terrain. We've done a lot of testing on the accuracy, and what we've seen is even though we're using a 15-meter Landsat scene that's basically a 30-meter multispectral that's been resampled to 15 meters with the black and white or the panchromatic Landsat band, we're getting around 20 meters in the XY in terms of accuracy, and we've measured that against high resolution, high accuracy aerial photography. So being able to state that we have about less than a 20-meter, on average about an 18-meter accuracy for this type of data that has not been touched by anyone, that's actually quite impressive. Not necessarily used for very highly engineering applications, but for land management, agricultural applications, it's very accurate. The other thing that we can do now, we just received a license from the US government. We can provide this data to our partners in an unrectified format. So if there is a particular region in Thailand where the accuracy requirements are even higher, and you have, let's say, high resolution aerial photography and a higher resolution digital elevation model, then our partners could process the data using those inputs to create higher accuracy ortho images. So we can provide the standard ortho-rectified image that we do automatically. We can provide the non-rectified imagery to our partners, and they can do custom, if you will, ortho-rectification to meet higher accuracy standards.
Hello.
ค่ะคำถามจากท่านต่อไปค่ะค่ะเชิญค่ะ
As of now, there are around 20 satellites flying in the sky, right? Can you share with us the launch schedule from now on until the whole operation complete?
Yeah, that's quite an interesting question. Typically when you hear about a satellite launch, it's like a once in a lifetime, or at least a once a year, if that, event for an aerospace company. We launch about every 60 to 90 days. Just to give you an example, we had 12 satellites that we delivered to the launch provider just a couple of weeks ago. Those satellites will be launched in April to the ISS, and they will be released in May from the ISS. And then we have, again in June, we have, I think it's 24, thereabouts, 24 satellites that will be launched in June. Again, so within the span of from April to June, that is over 40 satellites that will be launched. That gives you a sense of how rapidly we're launching. We also have some very large launches scheduled for the end of this year and early next